Okay, hi guys, so we'll be seeing more examples on the calculation of rate of reaction using the RDS and steady state approximation method. So let's get started with another example. So suppose 2 moles of ozone or O3 gets converted into 3 moles of O2, and we have this broken down into steps. So the first step is O3 first converts at equilibrium to O2 plus O. So this is rapid reversible step. And in the second step we have O3 plus O gets converted into 2 moles of O2, which is a slow step. This is at K2. Okay, so for RDS we can write that rate would be equals to K2 times O3 and O, where O is the intermediate product, and as per our assumption we can write that rate of forward direction would be equals to rate of backward direction from step 1 assumption in step 1. So we can write rate of forward direction, which would be Kf times concentration of O3, would be equals to Kb times concentration of O2 and O. So from here we can derive the concentration of O and can put in first equation. So put concentration O from second into first. So we would be getting rate would be equals to K2 times O3 times concentration of O here would be nothing but Kf times O3 divided by Kb. This is O3 divided by Kb times O2. Okay, so we would be getting rate as K2 times Kf divided by Kb times O3 square, directly writing O3 square divided by O2. Okay, so rate can be written as K times O3 to the power 2 and O2 to the power minus 1. So this means that it's a first order reaction, because the overall order would be 2 plus minus 1, which would be 1. And this is K dash. Actually K dash would be equals to K2 Kf upon Kb. Okay, so next we will be seeing collision theory, new concept which is collision theory. So collision theory is, suppose A plus B gets converted into C plus D. So we can write that assumption is that first the reactant molecules are hard spheres, which means that when reactant molecules collide with each other, product formation takes place at the time of collision. Reactant molecules, or rather let me write it while speaking. So when reactant molecules collide with each other, product formation takes place. And second is that at the time of collision, reactant molecules must be specifically oriented with enough activation energy. So this point we have already seen in previous lectures, so I am again rewriting it. So at the time of collision, reactant molecules must be specific or rather specifically oriented with enough activation energy. Okay, and we can write rate would be equals to ZAB into P into e to the power minus EA upon RT. Okay, where ZAB would be the collision frequency or the number of collisions per unit volume per unit time. Collision frequency, which is nothing but number of collisions per unit volume per unit time. Okay, and P is the static factor or probability factor or orientation factor. Static factor or probability factor or orientation factor. Okay, and we can also write that more the complexity in reactant molecules, less will be the value of probability factor. More the complexity in reactant molecules, less will be the value of probability factor. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on collision theory. So till then, good luck and goodbye.